And now we are going to speak about an algorithm to cluster in feasible time a point in a space. So, first of all, we are going to remember from the last class the K-center clustering problem. Given a set of points data, find the K-centers minimizing the max distance. What we want to do, we wish to cluster a set of points defined in a multidimensional space into K clusters. And these K clusters are defined by K centers. It looks like a nice, well-defined problem. So the input is a set of points data and an integer K, or a set of arrays. An array defines a point in a multidimensional space, and an integer K, the integer K is a number of clusters and of centers. And the output will be a set of K points, centers, that minimizes the maximum distance between data points and centers. What I wish to have is a clustering that optimizes or minimizes the maximum distance between each point and the cluster. It looks like a quite well-defined problem. Unfortunately, this is not a feasible problem. It is part of the problems called the NP complex problems. So we cannot solve them. We need to find an approximation, and now we are going through an algorithm that can give us an approximation. So, first of all, we are going to reword the problem. Given a set of points data, find the K-center. I don't like it. Why I do not like it? Because I have a power n possible solution in a space to analyze using a brute force approach. And that is the reason for which this is not a feasible problem. In the modified problem, from power n, that depends on the dimensionality, if it is a bidimensional, three-dimensional, or a multidimensional space. I reduce the space of solution, of possible solution, to the set of points data. It is still a combinatorial complex problem, but it is not NP complex. So given a set of points data, find K of this set that minimizes the max distance between data and centers. I'll reduce the computational complexity of the problem in a huge way from power n, given n the dimensionality of the space, to the number of points in the dataset. And now I'm going to describe an algorithm that can approximate the solution given in a reasonable time. For the traversal, data NK. We remember data is a set of vectors containing the coordinates of the data, and K is the number of clusters. So we define a set centers and we initialize it randomly to the value of a single data point. As I said before, in this algorithm, I'm not analyzing the full space of solution, but only possible combinations between data points. So we have the set consisting of a single data point, and we have a while. This is an iteration. This symbol, it's a pipe, refers in this case to the number of elements in the set center. We wish to cluster data into K clusters with K centers. At the moment, center has only one element. So, while the number of centers is less than K, the data point, my apologies, I have to restart. I'm going to iterate while the number of centers is less than K. And in the iteration, I'm going to define a new data point that I'm going to add to the center. And which one I select? I select the farthest one. Given all the data points, I'm going to select the point in data that maximizes the distance between this data point and the actual center. Why do we want it? We want it because we wish the center of the data point to be as far as possible. And we add this data point to centers. And now we iterate until we are going to obtain K centers.